Hey all, welcome back to this is part 3 of the Algebra 1 final review guide. We're on point slope form. So point slope form is helpful for writing equations when we're given information. So one thing you can do is you can use y equals mx plus b, right? And you can solve for m and b, but really this is easier. Y minus y1 equals m equals x minus x1 helps us get there faster. I'll show you how, in certain situations. So let's say this one. Find the equation of a line if m is -2 and we have the point 2,6. Well, that's all we need for this, right? Remember that m is the slope and x1, y1 is just a coordinate. So if we have these two things, I'm sure you can see this over here. If we have those two things, then we're good to go. So let's plug it in. We're going to have y minus, this is going to be my m, this is my x1, this is my y1. So it's going to be y minus 6 equals -2, parentheses, x minus 2. That's it. Similar here, right? We're given the slope, we're given a point, we can just plug it in. Y minus 2 equals 1/3 x minus 3. Simple, okay? So have this on your note card, have it ready to use. Let's see a different problem. So here we're not given slope, but we're given 2 points. So if we think about the formula y minus y1 equals m x minus x1, we have like a y1 and an x1, and either one of these could be an x1 or y1, but we don't have the m. So we need to find the m. And we know m, slope, is y2 minus y1 over x2 minus x1. Okay, so when we choose our coordinates, x1, you want to choose that lowest x value as your x1, then this is your y1, then this must be your x2 and your y2. Okay? So plug them in, and we get -1 minus 5 equals 2 minus -1. So that's -6 over 3. That's -2. Okay, so that's my slope. So if y minus something equals -2 x minus something, right? And so in here, in these two spots for x1 and y1, I can choose either pair of coordinates, right? I know I said -1, 5 was x1, y1, but for this purpose, it doesn't matter which coordinate you put in. So I'm going to say y minus 5 equals -2 x plus 1, but you could have said y plus 1 equals -2 x minus 2, and either of those would be fine. Converting from point slope into slope intercept, so let's say like you have y minus 5 equals -2 x plus 1, and I want to make that slope intercept form. We're just going to distribute this to get y alone, right? So we're going to get y minus 5 equals -2x minus 2, and then we'll add the 5, y equals -2x plus 3. That's it. So we can just get y alone from any of these above. We'll get that slope intercept form. Okay. All right. So going parallel lines. If we are parallel, if the lines are parallel, that means that the slopes are the same, right? So that means that the slope of both lines, right, M1 and M2, these are two different equations, are the same. That would be a parallel line, okay? Find the equation of a line that goes to 2, 3, and is parallel to -3. So if it's parallel, it has the same slope. So we're going to say y minus 3 equals, the slope is -3 x minus 2. That's it. This is a new line. It goes through the this point here, and it has the same slope as this other line. That's it. Find the equation of a line that goes through negative 1, 5 and is parallel to this line. Well, this I don't know the slope yet. We got to get y alone first. So let's get y alone. We're going to subtract 10. We're going to subtract 10. We have 5x minus 10 minus y equals 0. And then I'm going to add y. So y equals 5x minus 10. So my slope is going to be 5. So I'm going to say y minus 5 equals 5x plus 1. Okay? Perpendicular line. So if it's perpendicular, that means the slope of one line is the opposite reciprocal of the other. That's what this means, opposite reciprocal. So let's say that the slope of line 1 was 2. Well then, the perpendicular line would be negative 1 over 2, right? If the slope of one line was just 1, it would just be negative 1 over 1, which is just negative 1. If the slope of one line was negative 3/5, that would be 5/3, right? You are going to flip the numerator and denominator and change the sign. We'll do one more. Let's do like 7/6. That would be negative 6/7. Okay. So change the numerator and denominator, right? 1 over the original slope, and then change the sign from negative to positive or positive to negative. So in these examples, find the equation of a line that goes through 2, 3 and is perpendicular to negative 3x plus 2. Well, my slope here is negative 3, so my perpendicular slope would be 1/3. Okay, so my formula is going to be y minus 3 equals 1/3 x minus 2. Similar here, this is nice for us, perpendicular. So this is 1/4, so my perpendicular line would be just negative 4. So this would be y minus 5 equals negative 4 x plus 1. Okay? All right, chapter 5, solving systems of equations. So systems of equations, the idea is you have two separate equations and you want to find out where they intersect. That's the idea. We're finding out where two different equations intersect. So one way we can do this is by graphing. So y equals 2x plus 3. We did this in a previous lesson. Y-intercept of 3, slope of 2. We can just go ahead and graph that. And then negative 3x plus 2 will be here. Right, and we're going to connect these dots. Okay, so this intersection point is the solution. Okay, so the intersection is the solution. Okay, so we have some weird solutions, right, when graphing. Okay, so weird solutions. Let's go ahead and graph 2x minus 5. That's y-intercept of 5, and then a slope of 2. And then we've got the second one. We're just going to get y alone here. So 4x minus 6 equals 2y. 2x minus 3 equals y. Right? What I did there was just add the 2y over, and then I divided by 2. Okay, so this is plus 2y, and then I divided by 2 both sides here. Okay, so it's 2x minus 3. So we're here. So what happens is, what do we have? We have a pair of parallel lines. So these are parallel. Right, they're never going to touch. So this is no solution because they never touch. Okay, I need to keep putting my arrows on. Okay. And then this one, so y equals 3x minus 2, and then let's solve this one. So this would be 2y equals 4 plus 6x, and we divide both sides by 2, and we'll get y equals 2 plus 3x. So again, what all I do is I would add 6x both sides, then divide by 2. And notice that these two are the exact same. So this one has infinite solutions, right? Because they're like on top of each other, if that makes sense. So wherever you go, they're going to be intersecting. No matter what you plug in for x, they're always the same, okay? All right. So how do we solve them? That was graphically. How about algebraically? So one way we can solve them algebraically is if one of the equations has a variable isolated, we're just going to take that variable and plug it in to the other equation. So we know y equals 2x plus 3. We also know 2x plus y equals 7. So we're going to take this 2x plus 3 and replace it with this y. So we have 2x plus 3 equals 7. And we're just going to solve this. We have 4x plus 3 equals 7. That's 4x equals 4. That means x equals 1. And then we take this value that we get and we plug it back into one of these to solve for y. So I could say that 2 times 1 plus y equals 7, or y equals 5. Okay? Because I subtracted 2 from both sides here. Okay? So and here, so just combine like terms. I subtracted 3 from both sides, and then divided by 4. I got x, and I plugged it into this equation. You could have done this one too, and you would get 5. Here, notice how like no one variable is immediately isolated, but we can make them isolated right here. So I can say that x equals -1 minus y, right? All I did was move the y over. And so we have 2, -1 minus y plus 3y equals -5. And we're just going to simplify this. -2 minus 2y plus 3y equals -5. That means y equals -3. You take that -3, plug it back in. If y equals -3, then x must equal 2, right? Because that means x equals -1 minus -3, and that is 2. So x equals 2. So you should always have at the end an x and a y, a coordinate, okay? Using elimination, the idea is to combine the equations to cancel out variables. So see right here, again, we don't have a variable isolated, but if we add these together, we'll get 3x and then nothing, right? These will cancel, and then 3. So x must equal 1. And then I can plug that value in. Right, do you see what I did there? 2x plus x is 3x. Y minus y is nothing. 5 minus 2 is 3. We're just adding down. Then I have x. Well, then I can just plug it into this one. So 2 times 1 plus y equals 5. So then y must equal 3. Okay. Over here, same idea. But right now, they don't cancel if I add them. This is like a number of things you can do, but what I'm going to choose to do here is just multiply the top by 2. So I'm going to get 4x plus 6y equals 2, and then -4x plus 3y, that should be a 6y here, equals -11, and then I'm going to add straight down. Okay, so I multiply the top by 2, everything by 2, and then I'm going to add straight down. So I'm going to get 9y equals 9, y equals 1. We'll plug it back in. 2x plus 3 times 1 equals 1. That means 2x equals -2, so x equals -1. Okay, so here we're combining them so that they cancel, and then plugging in the solution back in. The final step is really similar in both of them, right? Weird solutions. So using substitution here, if I know that y equals 2x minus 5 and I plug it in here, I'm going to get 4x minus 2 times 2x minus 5 equals 6. Let's go ahead and simplify this. We get 4x minus 4x plus 10 equals 6. That's just 10 equals 6, but that's not possible, so this is no solution, right? So if you get an answer that's impossible, you know it's no solution. Elimination here, if we multiply the top by 2, right, we got 6x minus 2y equals negative 4, and we added these two together, we would get 0 plus 0 equals 0. So if you end up with this situation of 0 equaling 0, then it's infinite solutions. Okay? All right, chapter 6, last chapter of this video. We are going to go over rules of exponents. So, the rules of exponents. First, we have anything to the power of 0 is 1, right? So that means 3 to the 0, x to the 0, right? If it was like 3x all to the 0, every single one of these, anything to the power of 0 is 1, is 1, is 1. So we say a to the 0 equals 1. If it's to the power of 0, it equals 1, right? Whatever is in that parentheses, okay? See, if you had 3x to the 0, that wouldn't be 1. That would be 3 times 1, which is 3, because only the term to the 0 power becomes 1. 3 is not to the 0 power here, right? But over here, see, 3x all to 0 power, that's just 1. See the difference? Okay, negative exponent. For any integer n and any non-zero a to the negative n is a reciprocal of a to the n. All right, so big picture, all this is saying is if you have x to the negative second, that's the same as 1 over x squared. If you had 1 over x to the negative third, that's just the same as x cubed. The rule being that if you have a negative exponent, you can rewrite it as a positive exponent by moving it to the other side of the fraction. So x to the negative a could be 1 over x to the a, or 1 over x to the negative a can be x to the a. Okay? Product of powers. If you multiply powers with the same base, you add their exponents, right? All this is saying is x to the third times x squared is x to the fifth. Okay? When we multiply exponents with the same base, we add the powers. So example could be, that's an example. So the rule is a to the m times a to the n equals a to the m plus n. Okay? Quotient of powers. So when we divide x to the fifth over x to the third, we subtract, it's x squared. So x to the m over x to the n. As long as the bases are the same, we subtract x to the m minus n. If it's a power of a power, this is another common one, we multiply the exponent. So if we had x to the third all to the fifth, that's x to the 15th. Okay, so x to the m to the n is x to the m times n. All right, so when we multiply, we add, we divide, we subtract. When we power, we multiply. Power of product just means if we have x, y, all to the third, that's the same as x to the third, y to the third. So ab to the m equals a to the m, b to the m. And same, this is the same idea. With the quotient, it's like x over y, all to the third is x to the third over y to the third. So we can distribute that exponent to each term inside the product or the quotient. So a over b to the m equals a to the m over b to the m. Okay, so how do we do this? How do we simplify it? Well, in this case, we have x to the third, x to 0, y to the fourth, y to the negative second. Okay, so well, we know x to 0 is just a 1. So, okay, I can cancel that out. It's just a 1 right here. Y to the negative second, let me zoom in here. Y to the negative second, right, that's 1 over y squared. All right, then I've got this y to the fourth. That's going to stay in the x to the third. So I can rewrite this as x to the third, y to the fourth over y squared, right? And what can I simplify? X to the third is done. I can't do any of that. But y to the fourth over y squared, that's the quotient rule. We can just subtract. What's 4 minus 2? That's 2. So the answer is, I'm going to write over here, x to the third y squared. That's your answer. Right? Come back over here. Sorry about that. Okay? 3x squared to the third. We are going to distribute this power to everything on the inside. So we're going to have 3 to the third, x to the sixth. Okay, 3 to the third, that's 3 times 3 is 9, times 3 again is 27, so that's just 27x to the sixth. Okay, x to the eighth over x to the third, what we're going to do, we're going to subtract x to the 8 minus 3, that's x to the fifth. Okay, keep going, 3m to the fourth times 2m squared squared. Okay, let's do the right side first. So we're going to distribute this to all the exponents here. We're going to get 2 squared m to the fourth times 3m to the fourth. 2 squared is 4, so we have 4 times 3 is 12. And then m to the fourth times m to the fourth is going to be m to the eighth. Okay? 2/3 squared, that is 2 squared over 3 squared. That is 4 over 9. 4 to the negative second, that is 1 over 4 squared. That is 1 over 16. Okay? That is exponents. Okay. Nearly there. Radicals. So radicals are used when we are rooting. We are rooting something. So it's not just to the power, but it could be to the power, but we're also rooting it in some way. So this is nth root of a is like what times itself n times is a. That's what we're saying. Okay, so when we have a root with no number here, no n, that just means 2, right? So you don't see, there's an imaginary 2 that's here, but you don't see it. So okay, what times itself twice is 36? Well, that's 6, right? What times itself 3 times is 27? That's 3. Okay, so let's fill in some of these. What times itself twice is 49? That's 7. What times itself 3 times is 8? That's 2. What times itself twice is negative 16? That's not possible. There's no solution, right? Because every number times itself is a positive number. Okay. What times itself 4 times is 16? That's 2, right? But we're going to make it negative, so it's going to be negative 2. Okay. What times itself 3 times is 1,000? That's 10. What times itself 3 times is negative 8? Now this does have a solution. This is negative 2, because negative 2 times negative 2, that's 4, but times negative 2 again, that's negative 8. So we can get negative numbers with the cube roots, but not with the square roots. So we can rewrite radicals as rational exponents. Rational means fractions. So the n root of a is equal to a to the 1 over n. Okay, so the cube root of x is x to the 1/3. The square root of a, that's a to the 1 over 2. These are all the same thing. So 25 to the 1/2, that's really the square root of 25, and that's really 5. Negative 8 to the 1/3, that's really the cube root of negative 8, which above we said was negative 2. And 10,000 to the 1/4 is the 4th root of 10,000, and that's 10. Okay? The n root of a to the m is a to the m over n. So when we have an exponent down here, that is the numerator of our fraction. Right here, there was no exponent for ax and a here, so the numerator was always 1. But when you have a power, that becomes the numerator, the fraction of the exponent. This is x to the 2/3, right? So this is saying the square root of 25 to the 3rd power. And to evaluate this, okay, what's the square root of 25? That's 5, right? So this is 5 to the third. And 5 to the third is 125. Okay. Negative 8 to the 2/3 would be the cube root of negative 8 squared, right? The cube root of negative 8, we already said that's negative 2. So this is negative 2 squared, so that's 4. 10,000 to the 3/4 is the fourth root of 10,000 cubed. Well, the fourth root of 10,000, that's just 10. 10 cubed is 1,000. Okay. All right, last page, graphing exponentials. Okay, so graphing exponentials, we have y equals a times b to the x, where a is sort of the y-intercept and b is the growth factor, or the decay factor. So when b is greater than 1, it's going to be growth. When b is greater than, when b is less than 1, but it's greater than 0, it's going to be decay. Okay, so see how the 2 to the x here means that we're multiplying by 2, so it's going to be growing, and here we're multiplying by half, so it's going to be decaying. So you want to make a table, and it's good to start out with 0 and 1 for both of these. We do x, y, and 0 and 1. So plug into 0. When we plug into 0, we get 2 to the 0 is 1. 1 times 3 is 3. Okay, when we plug in a 1, 2 to the 1 is 2. 2 times 3 is 6. Let's do a 2 as well. That means 2 squared is 4. 4 times 3 is 12, right? So you can see we're multiplying by 2. Over here, plug in a 0, we're going to get a 2. Plug in a 1, you're going to get a 1. And plug in a 2, you're going to get a 1/2. Okay? So now we can kind of sketch from here. 0, 3, 1, 6. So it's going to be kind of shooting up, right? And as we move to the left, it is going to approach 0, like that. And that's called a horizontal asymptote, right? We're approaching 0, but we're not crossing it. Over on the right, we start at 2, then we go to 1, then we go to 1/2. So it's the mirror reflection, right? We're decreasing over time, and we have a horizontal asymptote at 0. Okay, that is it for part 3.